Hello, ladies and gentlemen. This was the lesson that we were going to continue on Thursday, the 18th, in preparation for our quiz on Friday, the 19th. What we are going to do, and I'm going to share my screen to kind of walk you through a couple different things here. We are going to review a section 4.2, which was on solving quadratic equations by graphing. Okay. We are still going to continue to progress through this review, and there will still be an assignment that I will talk about towards the end of this video, as well as I will put on Schoology for tonight also. Okay. So give me a second here. I'm going to share my screen and just share with you the folder that we are in. So Thursday 2/18. This is the graphing review that you see here. So this PDF file that I'm going to be working out of throughout this video is available for you to take notes on, to access. Also, the homework assignment, which I will touch on towards the end of this video as well, is to complete this third review in preparation for the quiz on Friday. The page numbers are there as well. Like I said, we'll talk about that more so towards the end of this video. Okay, what I want to do right now is just focus on this sheet here. And one thing that we want to recognize is that, let's turn the brightness up here. This is a situation where we're not going to be factoring or doing anything to solve for our solutions, but rather we are going to be graphing these solutions. Okay. And one thing that we touched on was if we are given an equation and we're not given a graph and we're not given a table, we need to recreate that. And there will be a question on your quiz where you need to be able to do that exact thing. Okay. So we're going to take a look at a couple examples here of when we would have to, create this graph, choose some points to find our solutions, and then kind of determine where they are at. All right. So I have 2x squared minus 16x, that should say there, the x didn't print, plus 31. And there was a formula that we needed to use in order to find what's called the vertex point of my equation there. Okay. And that was negative b over 2a. Okay. Negative b over 2a. That's going to give us the x value of our vertex point. And what that means is after my equation set equal to 0, because I always want to make sure it's equal to 0, I'm going to list out the a, b, and c values from this equation, plug it in to find the x value, and then work to find other points on my graph. So I know that my a is the number in front of the x squared, b is number in front of the x, c is the constant term. So a would equal 2, b equals negative 16, and c equals 31. I'm going to take each of those values, plug them into this equation here. Well, negative b tells me, I'm going to do the work down here. Negative b tells me it's the opposite of that sign, and it's that value. So it's, instead of negative 16, it's the opposite. It's positive 16 over 2 times my a value of 2. Well, that's 16 over 2 times 2 gives me 4. So my x value for the vertex is 4. And remember that when we find that x value for the vertex, we want to put that in the middle of our table. We'll take that 4 then and plug it back into the original equation to find what the y value is at that point. So I'll do 2 times 4 squared minus 16 times 4 plus 31. Okay. 4 squared gives me 16. One thing I do want to say before I continue on finding the y value, you can use a calculator. You can do this by hand like I'm about to do. Any resource that you need to find these values, I'm allowing you to do on the quiz on Friday or anytime that we're working through a question like this in class. So just so you're aware of that, I'm going to do this in my head here. We have 4 squared is 16. So I'll have 2 times 16, which is 32, minus 16 times 4 is 64, and then plus 31, because that's the lone constant term there. Well, 32 minus 64 is going to give me a negative 32. Plus a 31 is going to give me a negative 1. So I know that my y value at 4 is negative 1. And that is my vertex point. Okay, so remember the vertex, as I said earlier, is always going to go in the middle of my graph there, or my table, excuse me. And the reason that we put it in the middle is because, remember, we're dealing with a parabola shape. It's a symmetrical shape. That's the point right in the middle of it where it's even on either side. What I do now, what we talked about in class, is choose two values smaller and two values higher than my vertex point to plug into my equation. The reason we do that is because whatever the y value is we find for 2, because it's symmetric, will be the same value for 6. The value for 3 will be the same value for 5. So I only need to really do half the work there. Okay? I'm actually going to use my calculator for these as well. Like I said, use whatever you need to help find those solutions, or excuse me, those y values for this equation. So I have 2x squared minus 16x plus 31. When I plug in a 2 in for x, I get 7, which means for 6, I also have a 7. When I plug a 3 in for x, I get 1. So for 5, it's also 1. And what I want to do now is plot these points, draw my graph, and then determine not only how many solutions I have, but where are my solutions. So at 4, I'm at negative 1. At 3, I'm at 1. 5, I'm at 1. 2, I'm at 7. So all the way up here at 7. And at 6, I'm also at 7. So this is what my graph looks like. Okay. Now remember, if my graph crosses the x-axis twice, that means I have 2 solutions. Okay. So I know that for my answer, I'm going to put it there on the graph, I have 2 solutions. But now I need to determine where they're at. Well, if you remember back in class, we were able to look at the XY table there, where we had x f of x. Either way, we wanted to look at the table and determine, well, where are my zeros at? So if I can see a 0 visually, if there's 1, I have 1 solution. If there's 2, that means that it's at those x values. This is a case where I need to be a little bit more clever. I need to look at the transition from a positive to negative number because I don't have any zeros in for my y. So notice as I go along this graph, I'm all positive, positive, positive until I get to this point here and I cross over to negative. That takes place between 3 and 4 on my table there. So I know I'm going to have 2 solutions, and I'm going to say they are between 3 and 4. And also between, because notice I go from negative back to positive between 4 and 5, right? I go from a negative 1 to a positive 1. I do that between 4 and 5. So 2 solutions between 3 and 4 and between 4 and 5. Okay. And this is how you would answer your question on the quiz. So there'll be a text box provided. You would say 2 solutions between 3 and 4 and between 4 and 5. Okay. I'll give you a second there. Make sure that you have that down. We start with the negative b over 2a from my original equation, making sure it's set equal to 0. I set that up. I solve through to find an x value. I then plug that x value into my original equation, and that is my vertex point. From there, choose 2 points lower, 2 points higher, plug those into my original equation, and I get my y values. Remember, you only have to do half the work because it's a symmetrical shape. So whatever the value is for this should be the same for this. Draw your graph, determine how many solutions you have, and then work from there. Okay, and then that would be your answer. Sometimes you'll have zeros. In this case, you won't. Okay. Let's do the next example. I have x squared minus x equals negative 2. Excuse me, equals positive 2. jumping ahead of myself there because I need to make sure this equation is set equal to 0. So I'm going to subtract the 2 from both sides to start. And now my equation is x squared minus x minus 2 equals 0. Just like in solving by factoring, we want to make sure that our equation is set equal to 0. Just as before, I'll list my a, b, and c. My a value is in front of the x squared. There's no number there comparative to what I had in part A, but we know that that's just a 1, right? That's in place of a 1. B, I have a -1. C, I have a -2. I use my equation, that -b over 2a, to find the x value of my vertex. Again, the vertex is that lowest point or highest point if it's opening up downward. And it's that middle point in my parabola. So I'll do -1 or just +1 over 2 times 1. Okay. So that becomes 1/2. And that is the x value for my vertex. To find the y value, I'll plug that into my original equation. Again, you could do it by hand. I'm going to use a calculator for this. I have x squared minus x minus 2. I plug in 1/2 for x, and I get -9/4. Now, this one's a little trickier. We're dealing with some fractions. But what I want you to be aware of is I'm at 1/2. I'm at -9/4. That's 2.25 as a decimal, so you're around here. One thing that's different about this example, instead of going by ones as integers, you can go by a half here and here, and then start counting by integers. You should get the same thing for your values now. Okay. So for example, if I were to plug in 0, I should get -2. And if I plug in 1, I should also get -2. When I plug in 2 into my original equation, I get 0. And at -1, I get 0. Now, at first glance, right, we're dealing with fractions. We might not think that this is an easy problem to take care of. However, when I plug in those other integers, I get integer values. So I'm good. At 1, I'm at -2. So I'm around here. At 0, I'm at -2. So those points are pretty tight. At 2, I'm at 0. And at -1, I'm at 0. Notice my parabola intersects that x-axis twice, which, as we saw in the first one, means I have 2 solutions. And what's nice about this problem is, as we look at our table, because there will be some problems where you have to look at a table to determine the solutions as well. As we look at our table, notice that I know where those 2 solutions are. Wherever my y value is 0 or my f of x is 0, that's where I have 2 solutions. Those corresponding x values are where my solutions are. It's where it crosses that x-axis. So I know I have 2 solutions because it crosses twice, but I also know that those solutions are at x is equal to -1. And x is equal to +2. And this would be my answer that I would put in on the test, whether it's a text box or whether you have to type it in. 2 solutions at x equals -1, x equals +2. Okay. Again, we're all using the same steps. Set it equal to 0, list your a, b, and c. Use the -b over 2a to find your x value for your vertex. Plug that into an equation to find the y value. Choose values smaller than that. In this one, we did just a half smaller this time. Usually it will be integers that you'll work with. Plug each of those x values in. You only have to do the work twice because it's symmetrical to find the y's and then determine the solutions. Okay, so we've gone through a couple examples where we had to do that. For the next couple examples, what I want to do very quickly is to just show you the graphs of each of these. So the x squared plus 2x plus 1 here. And I'm just going to draw the graph out, and I want us to recognize the number of solutions that we would have based off of this graph, okay? So my graph actually looks something like this. Okay. And like I said, we've already shown the steps for how to do it if we're just given an equation, but on the quiz, you might be given just a graph, okay? Notice that my graph does not cross the x-axis, okay? It has an interaction with the x-axis, right? The x-axis is this horizontal line here. It just touches my x-axis once. Whenever it just touches the x-axis, that means that I have one solution, okay? So if you're given a question like this on the quiz, or you found that you have a graph like this after maybe finding the table and going through all your values, you would say that you have one solution when it just touches that x-axis. And the solution is at the point where it touches the x-axis. In this case, I'm at -1 when I touch the x-axis. So it'll be one solution at x equals -1. And that is how you would write your answer. So we see here in comparison, crosses twice, 2 solutions. Sometimes we'll be given a table with zeros, and we'll be able to pinpoint those exact solutions. Sometimes we'll be given a table and there are no zeros. We have to say it's between values based on when I go from positive to negative and vice versa. And sometimes I'll have a graph, and you would see in the table here where you have one solution, and it's at -1 in this case, when it just touches that x-axis. Recall that we have three different types of solutions. We have 2 solutions, 1 solution, and in this case, I'm going to sketch the graph of this. X squared plus 2x plus 3 looks something like this. Notice that my graph does not touch or intersect the x-axis at all, okay? When that is the case, our third type of solution that we can have is what's called no solution. So the difference in types of solutions, we have 2 solutions, crosses the x-axis twice, 1 solution just touches the x-axis, and then no solutions when it does not touch or cross or interact at all with the x-axis. Okay. That is it for the content that we were going to get through in class, okay, on Thursday if we did not have a snow day. What I want to do real quick is reference the folder again, because with everything done now, we completed that graphing review in this video. You can do page 234, numbers 20 through 28 even only on your own. You did the odds already in a previous assignment, so I want you to go back and do the evens now. And this should be a good refresher for you to be able to complete this assignment and get prepared for the quiz on Friday. Okay. The pages are here as well if you're struggling with, the hard copy of the book or even the online textbook. You're solving each equation for the exact roots by graphing it. Okay. So you want to make sure it's set equal to 0. You see that some are, some aren't. You want to use that equation -b over 2a to find your vertex, and then to go ahead and actually graph it, determine the number of solutions. Your table is going to be helpful for you. If you have a graphing calculator, you want to plug it in to check, that would be helpful for you as well to determine, do I have 2 solutions? Do I have 1 solution? Do I have no solutions? Okay, so to make sure that you use all of the resources that are provided for you to make sure that you are preparing for this quiz. So the assignment still goes even though we don't have class because this video was the lesson for it. Okay. Any questions for me, you can reach out to me via Schoology. You can reach out to me over email, anything that's going to be helpful for you. And I will get back to you to help you out with anything that you need for the review for the quiz on Friday.